Hi, I'm Rudraksha, and in this video I will be talking about the program I built for my Intro to Artificial Intelligence class with Thomas Fernandez. The program build is built using C++ in Visual Studio. The program is basically a game. It solves the pegboard puzzle. The user inputs the size of the pegboard. In inputs, he also inputs the start location and the end location of the pegboard. And along with that, the start location decides the position in which the position in which there will be a hole at the initial state, and the end position is the spot where the pegboard game should end, which will depict the solution state. The end location will also decide the termination criteria for the program, for the AI that I have built for finding the solution state. The program will then compute all possible iterations and find the path from the initial state to the solution state and display the solution states on the screen in the order they occur. Now, one thing we need to note that the pegboard problem, though solved, always does not have a way from the initial state to the final state. It might be that there might not exist any path from the initial state to the final state. So it is required that we play around with it and we try to find out which states are possible solution state and which are not possible solution state, which we'll go over in a minute. So let's play and understand that how this code works first. So we have a class that is pegboard class, which is inside the header, and the pegboard class consists of a lot of consist of the matrix. The entire pegboard is initialized in the form of a matrix, and whichever size the user inputs, that size matrix is initialized with the help of the constructor, and the destructor destructs it, like destroys it at the end. So we do not have to worry about garbage collection doing the work for us. Then the pegboard matrix that is shown in this image is the matrix that actually stores the value of the value of the states inside the matrix, where 1 equals to an existing pegboard, or then where 1 equals to a peg on the pegboard, and 0 equals that there are no pegs on the pegboard. There are many functions that are defined inside the class so that we can perform the following. We can perform the function that the AI can perform its function of finding the possible solution state from the given initial and final states. So there are functions like create pegboard, set positions, clone a pegboard to create a deep copy of the current pegboard, position check, get final position, is on board. Is on board is a function which checks whether the value that is being checked is on the board or not. Is it outside the board, outside the matrix or not? And it gives a returns a true or a false value based on that. Is occupied does the same thing. It finds out if the pegboard that is being checked, the position on the pegboard that is being checked is occupied by a pegboard or not. And is not negative does it speaks for itself. It's the same. Another function here is a constructor and the destructor just below it, and I'm closing all the definitions so that it remains clean. There it is commented. I've commented everything to say what it has to do with it, what the function does, and these are all the members of the class pegboard. Now let's go to the source code. The source code is basically a depth first search. The program is basically a depth first search, where the depth first search begins with creating a stack for all the pegboard positions that are generated from a given pegboard position that it can possibly go to from a given position. Then an initial parent index is set in the pegboard, and a new object current pegboard is created which handles each and every pegboard that is being checked. Then we go inside the while loop, which terminates only when the stack is empty. At this point, we remove the pegboard object, the first pegboard object, whose parent index is named as -1, from the pegboard and put it inside the stack. and then we pop it and push it inside the vector. Now that is being checked. Now for the current pegboard, all the positions on the pegboard, let's say the first position, the second, the third, all the positions will be checked with these 6 if statements to check whether any of the position, for any given position, there is a valid move from that position. After it checks them, for each position it will create a new pegboard. It will create the board. It will clone the pegboard with the current pegboard. Then it will change the following locations, like ij should be equals 0, I plus 1 and j plus 1 should be equals 0, and so on. It will change the location and then push this pegboard inside the pegboard stack by before changing, no, wait, after changing its parent index to the size of the pegboard minus 1. I do this because whatever is inside the vector at this point is the parent of this state. So the last object in the last pegboard inside the vector is the parent of this pegboard state. So I initialize the last object's position to the parent index indicator of this pegboard position. That way I can keep track and backtrack it once I find the solution state. So after it iterates through all the positions, it goes back up and again pops the last thing inside this last pegboard position inside the stack and puts it inside the current pegboard, and then reiterates for all those positions. The same process goes over and over again. And while it is going on, it also checks for a winning condition, which is over here. The winning condition is check final state. In this check final state, it goes inside this, taking the current pegboard with it, and it checks the entire pegboard whether the final state has been achieved or not. Whichever final position is specified, except for that, all other positions should be empty, and a pegboard should exist only in the final position that is specified by the user. If it finds such a state, then it returns true and breaks the while loop and comes out of the while loop, taking current pegboard with it. Now we have the current pegboard, and at this point I initialize a new vector, which is winner vector, which consists of all the winning states, and it iterates through the entire vector of pegboards with the help of the parent index of the current pegboard. It goes and iterates and it pushes back each and every parent of the current pegboard, so that we have the solution state. Then its parent points to the parent index points to the parent pegboard position. Then that is pushed inside the winning vectors. Then we have the parent index of that pegboard position pointing to another parent. That is also pushed, and so on. It is pushed till a state where the original state, that is the first state, the current pegboard with parent index minus 1, is reached, and the while loop breaks from this point. Now we print the entire winner vector out on the screen, which is a solution state, which we will see in the next moment. So now let's run this program and check to see how it works. So initially, the program asks for the dimension for the pegboard. So let's say we give it a 5 cross 5, so it's going to be a 5 cross 5 pegboard. And let's say the initial position, I set it to 0, 0. And the final position I set to, let's say, 4 and 2. Now it's going through the thing and it iterates through it and it gives the final answer. So now let's go through the entire iteration and see how it solved the entire pegboard. So first, this is the 0, 0. This is the original position. There is no peg over here and the entire pegboard is full because one states that there is a peg in that position. Then the next state, this one crosses over this one and comes to this position by removing this one and this position. So we have 0, 0 over here. Next, let's see what happens is this peg moves to this position, removing this peg. So this 2 are 0 and this is 1. Now next is this peg moves to this position, removing this peg. So we have this 2, 0 and this is 1. Next, what happens is this peg moves to this position, removing this peg. So we have this two zeros and this one. Next, what happens? This peg moves to this position. Then, yeah, this peg moves to this position. We have this state now, and from here, this peg moves to this position. So we have now this state. That is step first. That's a sixth deep. That is six step deeps inside the state inside the depth first search. Now this peg moves to this position. That is this state now. Then this peg moves to this position, which is this state. That is four step deep inside the peg and then inside the pegboard into the depth first search. Then the next step is this peg moves to this position. So we have this pegboard state now. Then this peg moves to this position. So this is the final pegboard state now. And this peg moves to this position. So we have, oh, sorry. Yeah, scroll up. Okay. So this peg moves to this position, and this is the final state. And after that, this peg moves to this position, and this is the final state. So we saw that from here, it started as this as 0 and everything was 1. It iterated through the entire loop, find the possible positions, backtracked, and finally printed the solution state where we have this as the final position, which is 0, 1, 2, 3, 4, 4, 0, 4, 1, 4, 2. So this location was our specified final position, and we have reached our goal. But now we need to understand that though pegboard game is a solved game, it is still, there are many positions from which we cannot go from the initial position to the final position. When such a situation arises where there is no possible solution possible, the program terminates and says there was a problem. So let's simulate a problem. While I was testing it, I found one of those states, which is 0, 0 as the initial position, and final state is, let's say, 3, 2. And this state is not reachable from 0, 0. So it'll give an error anytime now. Yep, please try again. And so it gives an error and the program terminates. Let's try something else. Let's try 6 pegboard position. And the rules are the same. There are many positions for which the pegboard cannot solve it. And I was testing it and I found one position for which it solves it, so I'm using that. 0, 0, 4, 2. Oh, well, for this it doesn't solve it. I guess I was wrong. Well, not to worry. We can have other positions. We can try other positions too. If it doesn't work, we can try 6 and 1, 0, 4, 4. Let's see if this works. No, this doesn't work either. Well, let's try something else. 5, 0, 0, 4, 4. Oh, well, this worked. So see, we see the first initial position. Let's go up. Yeah. So we have the initial position. Then it takes the next step. That is this peg. This peg moves to this position, and so on. It solves it for this one. And similarly for, let's try some other position. Let's try that again. It should have solved it for 6 and 0, 0, 4, 2, because while I was testing it, it solved it for that one. Yep, it did. I think we had a problem with the stack or something. The stack overflowed or something like that, but it solved. And so yeah, we have our solution state, and this was our initial position set by us, 0, 0, and 4, 2 is the final position. So it iterates through the entire loop and checks for each solution state. When it finds the solution state, that is this 4, 2, It then iterates through its parents and stores inside the winning vector, and then prints out the entire possible solution state. As you can see, there are 19 possible solution states. I'm not going to iterate through them. They are the same. The peg moves from this position to that position, and all the possible states are shown. And well, this is the program. You can play around with it, and it's fun to see which states are possible, which states are not possible, which states are invalid. Thank you for watching.